Derivatives of trig and inverse trig functions.
The derivatives of the 6 trigonometric functions are: the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of tangent is secant squared, the derivative of cotangent is negative cosecant squared, the derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. This is analytically proving that the derivative of sine x is cosine x. First, we use the definition of derivative on sine x as h approaches 0 of sine x plus h minus sine x over h. Then, using the angle sum identity, you perform the derivative as limit h approaches 0 of sine x cosine h plus cosine x sine h minus sine x over h. From there, you factor out a sine x to make it sine x times a quantity cosine h minus 1 plus cosine x times sine h over h. Next, split that fraction into two separate fractions over h. From there, you have limit as h approaches 0, cosine h minus 1 over h is 0, and the limit as h approaches 0, sine of h over h is 1. Therefore, the derivative of sine x is sine x times 0 plus cosine x times 1, which is cosine x. We have just proved that the derivative of sine x is cosine x. Now we're going to prove that the derivative of sine x is cosine x graphically. So, given the graph of sine x, we know that at pi over 2 and 3 pi over 2, the slope of the tangent is 0, a horizontal tangent is 0. So on the derivative graph, there's going to be points at pi over 2 and 3 pi over 2 with the slope of 0. Now, between the intervals 0 and pi over 2 and 3 pi over 2 to 2 pi, we know that the slope of the tangents is positive from 0 to pi over 2 and 3 pi over 2 to 2 pi. So that means the derivative graph is going to be above the x-axis. Now, from the intervals pi over 2 to 3 pi over 2, we can tell that the slope of the tangent line is decreasing. So that tells us that on the derivative graph, it'll be below the x-axis. Here we have just graphed the derivative of sine x onto a new coordinate plane, and as we can tell, this graph looks like the graph of y equals cosine x. So therefore, we have just graphically proved that the derivative of sine x is cosine x.
Now let's do some practice problems. Given the equation y equals 2 sine x minus tan x, to find the derivative, you would have to do product rule in the first. So y prime would equal 2 times the derivative of sine x, which is cosine x, and then minus the derivative of tan x, which is secant squared x. Okay, given the equation y equals tangent of the quantity 2x minus x cubed, you take the derivative of the outside function first, so y prime would equal secant squared of 2x minus x cubed times the derivative of the inner function, which would be 2 minus 3x squared.
Next, we're going to find the equation of the tangent to the function y equals sine x plus 3 at x equals pi. So first, to find the derivative of the function, we take the derivative of sine x, which we just learned is cosine x, and the derivative of a constant is always 0, so plus 0. And technically, since there's a function on the inside, the derivative of the inner function is dx, which reduces to 1. Next, we plug in pi for x into the derivative, which we just solved was cosine. So y prime cosine of pi, which is y prime is equal to -1. It tells us that the slope of the tangent in the equation is -1. To solve for the rest of the equation, we have to use point slope form. So we use y minus blank, because we don't know what the y coordinate is, equals m, which is your slope, which we just solved to be -1, times x minus pi. In order to find the y-coordinate in this equation, we need to plug in pi to the original function. So on the side, let's do y equals sine pi plus 3. So evaluating this, we have y equals, the sine of pi is 0 plus 3. So the y-coordinate in this equation is going to be 3. So we can then plug 3 into our point slope equation. So y minus 3 equals -1 times quantity x minus pi. After distribution and adding the 3 to the other side, we will end up with the equation y equals -x plus pi plus 3. Derivatives of the inverse trigonometric functions are: the derivative of sine inverse is 1 over the square root of 1 minus x squared. The derivative of tangent inverse is 1 over x squared plus 1. The derivative of secant inverse is 1 over the absolute value of x times the square root of x squared minus 1. The derivative of cosine inverse is -1 over the square root of 1 minus x squared. The derivative of cotangent inverse is -1 over x squared plus 1. And the derivative of cosecant inverse is -1 over the absolute value of x times the square root of x squared minus 1.
Here's the analytical proof that the inverse of sine of x equals 1 over the square root of 1 minus x squared. Since it's the inverse, you switch the x and y coordinates. Then you take the derivative, which is dx dx equals cosine y times dy dx. And you know that dx dx equals 1. So 1 equals cosine y times dy dx. And you isolate dy dx and get dy dx equals 1 divided by cosine y. And then you solve for cosine y. So you square both sides to get x squared equals sine squared y. You substitute sine squared y for 1 minus cosine squared y. Then you isolate cosine squared y to get cosine squared y equals 1 minus x squared. Take the square root of both sides and substitute that answer into cosine y to get the inverse of sine x equals 1 over the square root of 1 minus x squared.
Now that we know the derivatives of inverse trig functions, we can evaluate the equation y equals the inverse sine of x squared. So first, we use chain rule to make the y prime. So we bring down 2 and leave the inner function alone. So sine inverse x to the first. And then we take the derivative of the inner function, and we know that the derivative of inverse sine is 1 over the square root of 1 minus x squared. And in this case, x in the function is x.
Now you simplify.
Yeah. To simplify further, we can make y prime 2 sine inverse x to the first, which is understood, over square root of 1 minus x squared. So you know that the derivative of inverse sine is 1 over square root of 1 minus x squared. We can evaluate the function sine inverse of 3x cubed minus 2x using chain rule. First, y prime is the derivative of sine inverse is 1 over the square root of 1 minus x squared. So in this case, x is this, your inner function, minus 3x cubed minus 2x squared. And then you also have to do chain rule of the inner function. So up here you do bring 3 down, so 3 times 3 is 9. X, drop a power to 2, minus 2. Then to make it into one fraction, we do y prime equals 9x squared minus 2 over the square root of 1 minus 3x cubed minus 2x squared.